Hey guys, this is the lesson notes for lesson 2.5, solving compound inequalities. For our class opener today, we're going to be graphing each of these inequalities. It's important that you remember the difference between open circles and closed circles. We're doing this in our Google Meet, so we're not going to show this piece here in this video. All right, we have 3 different learning targets today. Please make sure you write down all 3 of them. So the first one, I can write compound inequalities. The second one, I can graph compound inequalities. And then the third one, I can solve compound inequalities. All right, so there's a lot of information here on this page. I'm going to show you guys what I want you to write down. So I definitely want you to write down this stuff right next to here. So a compound inequality is an inequality formed by joining 2 different inequalities that have either and or. And then write down these examples at the bottom. So that will help you get a better sense of how this one works through. So again, compound inequalities have either and statements or statements. An and one is when you're going to have 2 different inequality statements that are both going to be true. And then it is going to overlap. So notice how this one on the bottom kind of overlaps itself. Both the endpoints come down, and then it's just up in the middle. Whereas the one on the right is an or statement, which means it's going to be 2 different sections that could be true. So this middle section is not true, whereas this section could be true and this section could be true. And when we write this, it has both statements being shown there. So when we look through this, we're going to want to identify different pieces. When you see the word and or, that's going to tell you when you're making your 2 different statements. So for example, the one on the left, the number x is greater than -8. So this is going to turn into x is greater than -8 and less than or equal to 4. So that also means that x is going to be less than or equal to 4. Again, you can write this all together because these would exist between. So you can write this as x is greater than -8 while x is also less than or equal to 4. We would graph this on your number line by having your dots at -8 and 4. You would have to have a closed circle on the right one, whereas on the left one you'd have an open circle, and then you would be drawing the lines in between. For the right one, number y is at most 0 or is at least 2. So at most 0 means y can be up to but not more than 0. It has to be at least 2, so y is going to be greater than or equal to 2. Again, you would have to go on your number line, use your 2 anchors, the 2 values that they give you, and in this case, because it's ors, it's going to be pointing out each direction. And in this case, they're both filled in because they both have that or equal to sign within them. All right, so then sometimes you're going to have to show these where you have to solve them more. So I'm going to zoom in on one at a time, but we'll work through these together. All right, so the one on the left, to solve this one, you'd have to add 2 to both sides. So now you'd be left with -2 is less than x, which is less than 5. So again, now we have our anchors at -2 and 5. these would both be open circles, and we'd be shading in between. For our one on the right, we first have to add 1 to both sides. So we'd have to subtract 1 to both sides. So we have negative 4 is less than negative 2x, which is less than or equal to 8. Divide both by negative 2. Remember, our signs need to flip, so then we'd be left with 2 is greater than x, which is greater than or equal to negative 4. So our anchors are at negative 4 and at 2. The one by negative 4 is going to be closed in. The one at 2 is going to be an open circle. And because it's an and statement, it's going to be shown together. All right, similarly with an or statement, you just solve it and then you work through. So let's see what that looks like. Okay, on the one on the left, we'd have to add the 5, so we'd be left with 3y is less than negative 3. And then y is going to be less than negative 1. For the one on the right, we add the 1, so we get 2y is greater than 6. Then y is greater than 3. So we have these two different numbers. We use both those as the anchors. 3 and the negative 1. It's going to be less than the negative 1. It's going to be greater than the 3. All right, example 4 here is our word problem. So it says electrical devices should operate effectively within the specified temperature range. Outside the range could cause the device to fail. So a lot of smart devices work between 0 degrees Celsius and 35 degrees Celsius. This problem wants us to write it in Fahrenheit. So obviously Fahrenheit and Celsius are two different measurements. You could quickly Google. When you Google, you would get the following equation to help you convert it. So the equation you get is Celsius is equal to 5/9 times the quantity Fahrenheit minus 32. So when we set these ones up, we want to set them up first as Celsius and then replace what we know in each piece. So you'll see what that looks like here. So down here I've solved the problem out. Let's talk through what we did first. The first thing that we did is that we set up, instead of having the variance of Celsius, we put the two endpoints given to us by Celsius, and we replace Celsius with our equation. Then, to go from first line to second line, we multiplied by 9 because there's a divide by 9 right here. Then, because it was a 5 times, we divided all three pieces by 5. So we got 0, f minus 32, and 63. Added the 32 to both sides. So we got the range of 32 degrees, 5 degrees. This should make sense, obviously, in our winter climate. You guys know that phones and stuff sometimes don't work out in the winter. All right, here is the homework for today. It shouldn't take too much. Use this as a resource to go back and forth with it.